For this last problem, we're going to do things a little differently. I'm going to start working my way through the problem, but you maybe don't have enough information to complete it yet. So once you get to a point where you think you can complete the problem, pause the video, work the rest of the way through, and see if you can get there on your own. And if you need me to do the whole thing, that's fine. But if not, stop it, work through. Okay? So this question is, if I mix these two solutions, will a precipitate form? And the way that we've done this in the past is just by looking at the solubility rules. But this time we're going to use KSP. And there are a couple of different options. So let's kind of look at what's going to happen, and we can kind of decide how to go from where we want to go. So I have a solution of NaCl, which is a solution that's aqueous, right? Which is really a mixture of the ions, okay? And I have a mixture of copper 1 nitrate, which is also a solution, which means it's also aqueous. So when I do the double displacement, I'm going to get copper 1 chloride plus sodium nitrate. Now sodium nitrate, if I look at my solubility rules, okay, salts of group 1 elements and nitrates are always soluble. So sodium nitrate is very, very soluble. So we're just going to call that aqueous. But copper 1 chloride, silver chloride, mercury 1 chloride, lead 2 chloride, which are insoluble. All right, copper chloride, maybe not. So copper 1 chloride has a KSP of this. So that's going to actually be the one that we're going after. So if I just wrote the, if I call this my solid, okay, if I just write the net ionic equation, I'm getting a chloride ion from here, I'm getting a copper ion from here, and I'm making this. Now, this looks like the reverse of a dissociation reaction, right? So CuCl solid makes Cu plus Cl minus, right? And KSP for this is concentration of Cu plus times the concentration of chloride ion. Okay? So remember that this was for a solution in equilibrium, which means that the product should equal KSP. Now, you're going to end up with 3 different solutions, okay? Or different situations. You're going to end up with KSP equals this, in which case you're at equilibrium. You're going to end up with KSP is actually greater than these two. Okay, so if KSP, the given KSP, is greater than the product of these two, no precipitate's going to form. Okay, because you're actually at an undiluted solution. Okay, an unsaturated solution. So no precipitate is going to form. Now the other way that this will happen is KSP is going to be less than the product of the 2 ion concentrations. Okay, we're not going to see a lot where these two are equal. It's really going to be this or this. Okay? And if KSP is greater than this, your concentration of ions is actually really too high. So what's going to happen is you're going to form precipitate. So you'll form precipitate until you get back to this situation where KSP equals the product of the ions. All right? So what we really need to do, we have KSP for comparison's sake. So we really now just need to calculate concentration of Cu plus and concentration of Cl minus. All right, so where are we going to get those from? Well, let's just take it step by step. Let's do Cu plus first. Concentration of Cu plus is going to be moles of Cu plus over liters solution. Now, we're talking about total solution here, like after you mix these things together. So our total solution, once we mix everything together, is going to be 35 milliliters. So we have that, but we don't have moles of Cu plus yet. All right? So the first thing that I'm going to do is a question mark moles Cu plus equals my given, which for Cu plus is going to be this information, 15 milliliters of a 0.083 molar copper nitrate solution. So this is milliliter solution, okay? And I'm just going to use molarity as a conversion factor, which means I need liters of solution, and then I can run that through my 0.083 moles CuNO3 over 1 liter solution. And then an important part that a lot of people kind of leave off is that I have 1 mole Cu plus over 1 mole CuNO3. Now I could give you a case where maybe this is CuNO3 2 or Cu2O or something like that. You know, you just got to be careful that you get the correct number of moles of Cu plus. And from that, I get 1.245 times 10 to the minus 3 moles of Cu, which I can then plug in up here. I just need to make sure that my milliliters get converted to liters, and when I do that, I get 3.557 times 10 to the minus 2. Now keep in mind that I'm only going to use 2 sig figs here, so I'm going to store all this stuff and I'm going to use full digits, but I'm going to keep track of things. Okay? If you're still with me here, if you haven't stopped the video to work ahead, do it now. Okay? See if you can get the concentration of chloride ion and figure out which situation we fall in here. Okay? So question mark mole, sorry, back up a step. Concentration of chloride ion is the other thing that I want, which is moles chloride ion per liter solution. And again, we have the 35 milliliters total solution, so I just need moles of chloride ion. I'm just going to get myself a little bit more room to work here. And I'm going to take this again from my given information. And use molarity. Okay, and this equals about 6.8 times 10 to the minus 4 moles Cl minus, okay, which I can then plug in up here. And again, I'm not going to round till I'm totally done. Okay, so here's 1 molarity. That's my molarity, my concentration of chloride ion. Here's my other concentration, the concentration of copper ion. So the product, what I would calculate as KSP, is the sum of those, 3.557, or sorry, product of those, times 10 to the minus 2, times 1.94, times 10 to the minus 2, and I get 6.9 times 10 to the minus 4. All right, so I look at this number, and I notice that this number is greater than the given value of KSP. So 6.9 times 10 to the minus 4 is greater than the given value, 1.2 times 10 to the minus 6, okay? Which means that I'll form a precipitate until I get down to this 1.2 times 10 to the minus 6 situation arises. So that's how you do these. They're fairly long, involved problems, but as long as you take it step by step, you should be able to get there.